Okay, I am now recording. We will get started here. I'm going to get this video posted this afternoon. I do know that a few people have been going and watching the videos after I get them loaded. So I don't know necessarily who's doing it, but I know that some people are going to the YouTube video. So I'm just trusting that everybody's going to get the content that they need. Just as a reminder, you have a test on Tuesday, and that test, I believe, is 40 questions long. Again, it'll go live on Tuesday, and if any of you have conflict with that and need to schedule a different day, let me know. Chris, I believe that I have already made it available to you.
Okay, good.
So you can check on that, and if you have any issues, let me know. But last night when I finished it, I made sure to go in and set it so that you should be able to access it by now.
Sounds good. Sounds good.
Yeah, if you go through that and you see anything that might be a little bit troublesome, just let me know and we can make some revisions from there. So today is the last official new content lesson. Today is the first or the last time that we're going to introduce anything new. So then on Tuesday of next week, you will take your test. On Wednesday, I will go in and I will go through all of your tests. Again, you'll have 2 opportunities to take that test. The higher score will be kept. I will look at your tests and see if there are any areas where the computer might not have given you partial credit that I would, and so your scores could adjust upwards. And then next Thursday, we will go through the final exam review. I will also talk about the final exam, how many questions are on the final exam, the kinds of problems in the review that will be particularly beneficial for you to study for the final exam, and so forth. I also know that Chris will intersperse some SI sessions along the way. And I will probably, let me start over because I haven't thought this through. I'm about to go out on a limb that I haven't thoroughly tested, but I'm going to do it anyway. So the Tuesday of finals week is like I think it's the 5th or something like that. The final is, okay, Chris is nodding. So the 5th is the Tuesday of finals week. We will not have, normally we would not have class on that day. Okay, normally we would not have class on that day during finals week. However, I will go live in a Zoom classroom setup at 10 o'clock on that Tuesday, May 5th, for anybody who has any questions about the final exam. So I'll be holding virtual office hours, and I'll do that from like 10 to 11:30 or whatever. Anybody can log in and ask any questions that they want to. I know Chris will probably also have SI sometime in that finals week to help you prepare for the exam. Chris, send me an email reminder to send you a copy of the final exam, if you would. It just occurred to me this minute. I hadn't thought about it. I sent out final exams to all the other M100 instructors, but I just this minute realized you don't have a copy of it. So if you can send me.
Are you going to open it up that day and then have it due back that day? Or are you going to give them like a couple days, or how's that going to work?
Great question. So I am going to give you guys 24 hours. I'm going to put that exam up on Thursday, May 7th. It'll go live at midnight, and you will have until 24 hours to get the exam downloaded or printed out, completed, scanned, and sent back to me. So you'll have an entire day to do that. And Chris, you can just text me. You don't have to email me if it's easier. Just text me and say, send me a copy of the final. I've got them ready, so I can do that. It's pretty much standard to what you've been used to, although I did have to make some edits because we cut out section 13 and so forth. So anyway, all right. So that's all the information that I think I need to share. Does anybody have any questions before we get started? Okay, Braden is here. I want to make sure I get him down. 1, 2, 3, 4, 5, 6. Okay. So there's 9 of you that are here right now, plus myself and Chris. We're going to go ahead and get started. As I said, for those of you who joined a couple minutes after I started the session, today is definitely a day when you want to be here. I'm glad that you're here. I wish that more were here because there's a lot of content today. And I think Chris said it pretty well. He said it's not really hard, but there's just a lot. And teaching it over a Zoom call is going to be a little bit challenging. I think I'm going to be okay with it. I've uploaded the notes for 14.3 and 14.4, and I want to definitely encourage you, if you haven't, to get those printed out or pull them up on your computer so that you can look at them. I'll be popping them up on the screen as well. So what we're going to talk about today, we'll start with section 14.3, and this section is called Measures of Dispersion. Okay, so I'm going to go ahead and share that section here on the screen and talk through it. So measures of dispersion. Okay, hopefully you can see that. See the little picture here, some free money. Is that appearing for you, Chris? I just want to make sure we're good. Great. Okay. So in 14.2, we talked about measures of central tendency, and that's looking at the way that the data tends to cluster toward the middle. And this is very useful, but it doesn't often tell the whole story when we're looking at data. So for example, here's an interesting example that I borrowed from the book and I expanded on a little bit. Let's say that there's some guy on campus, generous guy, and he's going to give away money to 6 different people once a week for the next 3 weeks. So in the first week, he gives out $24 to one person, $25 to 4 other people, and $26 to the last person. Now the next week, he comes into campus and he gives out $1 to somebody, $2 to somebody, $3 to somebody, but then he gives out $47, $48, and $49 to 3 other people. And in the third week, he gives out $10, $15, $20, $30, $35, and $40 to 6 different people. Now, what's interesting about these 6 sets of figures, these 6 sets of, these 3 sets, I should say, of data, is that all 3 of these monetary distributions have the same mean and median values. In other words, if you were to add these 6 digits together and divide by 6, or these 6, or these 6 and divide by 6, they all come out to be the same, $25. And if you were to find the median, which is of course the middle of the middle 2 scores, they all have the same median. Now, if you were one of the people during the first week who, let's say you were the person who got $24 and you found out that other people got $25 and $26, it probably wouldn't bother you too much that somebody else got $1 or 2 more than you. You'd be like, cool, I still got 24 bucks. But in the second week, if you're the person who gets $1 and you find out there's 3 other people who got $47, $48, and $49, you're gonna be like, well, gee, that's kind of lame. And the same thing here in week 3. If you got the $10, you might be kind of envious that somebody else got the $40. So what this means is that even though the mean and the median are very valuable pieces of information, they don't often tell the whole story. Measures of central tendency are useful, but sometimes they're limited in what they tell us. Sometimes it's helpful to look at other measures, statistical measures, to get more information. So the first one that we're going to look at is a measure of dispersion that measures the spread of the distribution, and it's called the range. And this is the easiest piece of information, statistical information, that you're going to have to calculate. It's easier than the mean or the median. It's easier than standard deviation that we're going to look at today. Probably the only one that's more simple would be the mode, because the mode is just a matter of looking to see what occurs the most frequently. But the range is a very simple calculation. All you have to do to find the range of a set of values is to take the largest value minus the smallest value and calculate it. Now, it is important that you understand that if the data is not in numerical order, you need to put it in numerical order, or at least identify the biggest and the smallest numbers first. Don't just take the first number minus the last number. Make sure that the numbers are in order. So here you've got an example of some data, 3, 4, 6, 7, and 9. Okay, fairly close together. The range is the highest value, 9, minus the lowest value, 3. 9 minus 3 equals 6. Okay, so pretty simple to find a range. And the range can be very useful. However, one problem with the range that makes it not always as useful as it could be is that if you have one piece of information called an outlier is a piece of data that's far, far away from other pieces of data. If you have an outlier, that can dramatically affect the range. So for example, here we've got some scores, 2, 2, 2, 3, 4, and 100. Well, if that 100 wasn't there, I'm going to take it away just for a minute. If that 100 wasn't there, these 5 scores are very, very close together, and they have a range of 2. But because there's one outlier, one piece of data that's really far away from the other pieces of data, it makes the range very, very large. 100 minus 2 is 98, as most of you know. Most of the data is really, really small, but you've got this one number way out here that is so much further away from everything else that it skews the range, and it doesn't tell us a lot. So even though the range is very easy to calculate by simple subtraction, it doesn't always give us the best information. So we need another way to look at the way that data is dispersed across the range than just simple subtraction of the highest and the lowest values. So I want to pause for just a moment and see if there are any questions about the range or how to calculate it. Okay. So now we're going to move on to what's called the standard deviation. The standard deviation is a better way to find the dispersion of data. And first of all, let's look at what does it mean to deviate? To deviate means to veer away from something. So for example, if you are driving down the road and all of a sudden a deer jumps out in front of your car. Many of us have experienced that. I've unfortunately hit a deer in my time. But if you try to swerve so that you don't hit the deer, what you're doing is you're deviating from your path. To deviate means to move away from. Another word that's based on the word deviate is deviant. Deviant behavior is something that is that moves away from what we consider socially normal behavior. So to deviate means to move away from. Now, when we talk about standard deviation, obviously if something is standard or standardized, that means that it's made uniform for everything. But what is this deviation? What does this deviation mean? Well, when we talk about standard deviation, what we're talking about is how far away from the mean a score is, or how far away from the mean it deviates. All right? So remember that the expression for the mean is this x bar right here. We're going to be using that. And if a value, an x value, deviates from the mean, we represent it by the expression x minus the mean. So in your book on page 749, and I'm not going to go to the online book, I've got it pulled up, but I don't want to deviate from this page, haha. But if you have your book and you look at the bottom of page 749, this image is down there at the bottom of 749. And they give us these values. They give us the values 16, 14, 12, 21, and 22. So what we've done is we've put those values on a number line in numerical order. You can see them here. These are the same 5 scores. And if you calculate the mean, if you add together 16 plus 14 plus 12 plus 21 plus 22, you get 85. And when you divide 85 by 5, you get 17. So the mean for this set of data is 17, the average or the mean. You can see it right there in our image. Now, all of the scores are either less than or greater than 17. So they deviate from the mean by a certain amount. For example, the 12 is 5 less than the mean. So if you take 12 minus 17, the value x is 12 minus the mean x bar of 17. 12 minus 17 is negative 5. 14 minus 17 is negative 3. 16 minus 17 is negative 1. And then, of course, 21 minus 17 is a positive 4, and 22 minus 17 is a positive 5. So these values up here, the red ones are the negatives, the blue ones are the positives, are the distance that each of the values deviate from the mean. Cool. So what we want to do is we want to find the average value. To find a standard deviation, we want to find the average deviation from the mean. But we have a problem. The problem is that when you find the deviations from the mean and you want to find the average of that deviation, if you add all these scores together, if you add the red scores and the blue scores together, you'll get 0. And that will happen virtually every time you do a problem like this where you're finding the deviation from the mean. As long as the mean is an integer and you don't get any funky fractions or anything like that, your sum of your deviations from the mean will add up to 0. Well, that's not very useful. So we need to do some mathematical manipulation that will help us to find that deviation. So the first thing we're going to do is we're going to create a table. And this table down here, this brown table, is the same table that's at the top of page 750 in your book. So what we do is we write down the data values. And I wish they had put them in numerical order. I'm a big fan of putting things in numerical order. It's probably a little bit of my OCD, but I like things in numerical order. They didn't do that. It's not going to affect things. So the way they put the numbers in this table is exactly the way the numbers appeared in their charts, in their list, 16, 14, 12, 21, 22. So those are the X values. And then we calculated those deviations, -1, -3, -5, 4, and 5, based on those numbers. So here's what you're going to do, folks. You're going to square these deviations. You're going to multiply them times themselves. Remember, when we square something, we multiply it by itself. So this is -1 squared is a positive 1. -3 squared is a positive 9. -5 squared is a positive 25. 4 squared is 16. 5 squared is 25. The reason we do that is that when you square any number other than 0, your result will always be positive. And if we have a bunch of positive numbers, then we can add them together and we can find the average. So, and that says that over here. In order to avoid all the deviations canceling each other out, we square each deviation. And here's the values of those deviations squared. Now, here's something that's very important. I want to pause for a minute before we go on to the next step. I want to explain something to you. It's so important that I've even put an image of it over here on the right side. We know that when we find an average or a mean, we divide by the number of values. Now, when it comes to standard deviation, there are 2 types of standard deviation that exist. There's a population standard deviation that you would use if you're examining an entire population of something. And there's a sample standard deviation when you're just taking a small group. So for example, if we wanted to use a population standard deviation to examine some information about IUN, we would take the IUN student body. We would take every student in the IUN campus. Okay, there's 4,000 of them or something. And let's say we wanted to find their ages and we wanted to find the standard deviation for their ages. Well, if we had every student on the IUN campus and we had their information, we would use a population standard deviation. Now, on the other hand, what if we just wanted to do it for our class? Our class is a sample of the population of the university. It's not the entire university. So when we do a sample standard deviation, we don't divide by the full number. We divide by the number minus 1. Okay? We divide by, in this case, we have 5 scores. We're going to divide the sum of these 5 scores by 5 minus 1. We are always going to do that for every problem in our class. We are always going to be looking at sample standard deviations. We are not going to be doing any population problems. So it's important for you to remember that after you add these values, oops, forgot that's not a table I can move, or that I can highlight. If we want to find the sample standard deviation, we're going to add these values together right here, 1, 9, 25, 16, and 25. You can see I've done that down here. And we're going to divide by 5 minus 1, or 4. So when we do that, and again, I want to stress, we will always divide by the number of scores minus 1. When we do that, when we sum those values, we get a 76. 5 minus 1 is 4, so we divide 76 by 4 and we get 19. This value 19 is not the standard deviation. It's the score we get before we find the standard deviation. We've got one more step to do. But before we find the standard deviation, we get this value, and that value is called the variance. Your book doesn't talk a lot about the variance. It references it just like once, kind of in passing. But I want you to make a note of it, because on your final exam, you are going to be given a set of data, and it's going to say, for the following set of data, find the mean, median, mode, range, variance, and standard deviation. You're going to find all of those measures. So make sure you understand that the variance is the score you get after you divide the sum of your deviations by n minus 1. So 19 is our variance. Now, one more step. The last step will give us the standard deviation. All you have to do is whatever your variance is, you take the square root. You can see that right here. To find the standard deviation, we take the square root of the variance. And people will say, well, how far should we round that? In general, I would encourage you to round to the hundredths place, which is the second decimal. That's going to be very important when we get into section 14.4 and look at what are called z-score tables. We're always going to round to the hundredths. So I want to encourage you right now, just round your variance to the hundredths. I'm sorry, your standard deviation to the hundredths place, and you should be fine. So again, what did we do? We found the deviation from the mean. Well, first of all, we found the mean. Then we found out how far each score was from the mean. We squared each of those values. After we squared those values, we added them together. Down here, we added all of those squared deviations together. We divided by the number of scores minus 1. So 5 minus 1 is 4. We got this value, which is our variance. And then we took the square root of the variance to find the standard deviation. Here's the formula for it, okay? S stands for standard deviation. So you're going to take the square root of this whole thing, but it's the sum of your deviations from the mean squared divided by n minus 1, the number of scores minus 1, and then you take the square root of the whole thing. That's the formal formula for it. Let me pause for just a moment. We're going to do another problem, but I want to see if anybody has any questions before we move on to the next example. Also, I see Eliza's here. I want to write that down so that she knows that I saw her. Any questions? Okay. Well, I want to remind you that when I am sharing my screen, I can't see all your faces. So if I'm doing something, if I'm doing a problem and you need to stop me, just unmute yourself and say, Mr. Becker, I have a question. Don't be embarrassed. Don't be afraid to do it. I will immediately stop and we will handle your question. I'm really grateful that we as a class had 8 weeks together to get to know one another before this all happened, because I'm teaching a couple of classes online during the summer with students that I won't have developed a relationship with, and I just know that they're going to be afraid to stop me and interrupt me and ask questions. And so I'm grateful that you guys aren't going to be afraid to do that. You can also, like Jordan did earlier, you can type something in the chat box. So however you want to do that is perfectly fine. So let's go back and look at another problem. Hang on a second here. I'm sharing the wrong one. 14.3. There. Why is that coming up? Hang on a second here. Here we go. So let's look at example 2 on page 751. Again, I pulled some of these images from the book. So I didn't really think about the fact that we didn't get much of a fun spring break, so maybe this problem isn't the greatest one, but we're going to go with it anyway. So you're planning a spring break, and you're going to go to, you're visiting some friends in Philadelphia, and you're going to fly from Philadelphia to Orlando. And so you're looking at airline flights, and you found some. Okay, you found 1, 2, 3, 4, 5, 6 different airline flights between Philly and Orlando. And these are the prices. Now, first of all, folks, the very first thing, if you need to make a note of this, I encourage you to do so. The first thing you need to do when you find a standard deviation is to find the mean or the average. So you're going to add all these scores together, 1, 2, 3, 4, 5, 6 scores together. When you add them together, you get 1260 divided by the 6 scores is 210. That means that the average flight cost is $210. Now, of course, when we look at those numbers, we see that some of those values are above 210, some are below 210. So next, we're going to find their deviations from the mean. So we list all the prices, all 6 prices here, and then we take the value, the price value, minus the mean. 195 minus 210, 213 minus 210, and so forth. Notice one of the prices is exactly 210, so 210 minus 210 is 0. No problem. This value right here of 210 does not deviate from the mean at all. So after we find these deviations from the mean, we square them. Negative 15 squared is 225, 3 squared is 9, and so forth. 0 squared is 0. So these values right here are the squares of the deviation. And now we add them together. When we add those squared deviations together, we get 344. Now we're going to divide that 344, the total of the sums of the squared deviations, we're going to divide that by the number of scores minus 1. 6 minus 1 is 5. And when we do that, we get a variance of 68.8. Again, I want to highlight the variance. Because again, the book doesn't talk a lot about it. It references it kind of in passing, but you are going to see it on your final. So the variance is 68.8. And by the way, that's exactly what it is if you divide it out on your calculator. It's 68.8. It's not rounded or anything. So take the square root of that value of the variance. And when you take the square root of 68.8, you get 8.29. That's rounded to the nearest hundredth. So this data has a standard deviation of 8.29. Are there any questions about how we got that?
Could you scroll up for just a second?
Sure. Go ahead, Christine. Do you have a question or you just need to see that?
Yep, I just need to see the box one more time, the top of it.
Right there?
Yep. Thank you.
Okay, no problem. And just for reference, again, this is on page 751 in your book, so you can check that out as well. We good? All right, awesome. So the next thing we're going to look at, we talked about this in 14.1, is frequency distributions. I hope you guys remember that concept. Frequency distribution is a table that we make when we've got a whole bunch of data and we see a lot of things that are occurring at the same value. So example number 3, and this again is from your book. This is page 752 in your book, and I took some images from the book to use it. So Anya is considering investing in Appeal, a software company that specializes in smartphone applications. So she's going to compute the standard deviation of its recent prices to measure how steady its stock price has been recently. The following are the closing prices for the stock for the past 20 trading sessions. Okay, so let me sum it up for you a little more concisely. Anya wants to invest money in a company, but she doesn't want to invest in a company that's not very stable in terms of its stocks. So she goes back and looks at the last 20 days to see what the stock price was. And these are the results. On day 1, it was at $37, day 2, $39, day 3, $39, day 4, $40, day 5, $40, and so forth. So 37, 39, 39, 40, blah, blah, blah. You can see all these values. And if you look through them, you'll see that the values that occur are 37, 38, 39, 40, 41, 42, and 44. There is no 43. On the 20 days that she was looking at, it didn't close at 43. So those are the closing prices. And you can see it in this table right here. Then she records how often it finished at that price. So there was one day where it closed at 37. There were a couple days it closed at 38. There were 5 days that it closed at both 39 and 40. By the way, going back to 14.2, those would be the mode, because those are the most frequently occurring scores, 39 and 40, and you can have 2 modes. It closed at 41 4 times, 42 a couple times, and 44 1 time. Now, recall that the most important thing that you have to do, the first thing that you have to do when you're calculating a mean, when you're calculating a standard deviation, is to find the mean. Kind of misspoke on that. So how do we find the mean for a frequency distribution? We talked about this in 14.2. You're going to multiply the rows together, the value times the frequency, in this case 37 times 1, 38 times 2, 39 times 5, and so forth. You're going to multiply the first 2 rows together, or columns together, and you're going to get these values over here. After you've done that, you're going to add that column together. And when you add these values together, you get 800. You're going to divide that sum by the total frequency. Not the frequency minus 1, folks. That's only for the standard deviation. We divide by the total number of scores, which is 20. So 800 divided by 20 is 40. So that means that the average closing price over those 20 sessions was 40. So now that we know the mean, we're going to set up a larger table that's going to allow us to find the deviation. So we got a couple of different things to do in here. I want you to notice that this table right here where we found the mean is the first 3 columns of this table. Closing price, frequency, and the product of those 2 columns. And then we've got 3 more columns. On your final exam, you're going to see a problem like this. In fact, I've given you a practice problem in your notes. All you have to do here is kind of follow the pattern that we're going to walk through up here to practice this problem. I did not give you an answer key for it yet because I want you to work it out on your own, and then I'll post an answer key later for this particular practice problem. But again, this is in your notes, in your Zoom notes, in that folder for you to print out. But anyway, going back here. So our first 3 columns help us find the mean. In the 4th column, we're going to find the deviation. Now remember, the mean is 40. So the deviation is going to be the x value minus 40. The x value is the value in the first column. So 37 minus 40, 38 minus 40, 39 minus 40, 40 minus 40, 41 minus 40, 42 minus 40, and 44 minus 40. It's important to tell you right now, before we go any further, that when you're doing a frequency distribution, the sum of your deviations will not necessarily add up to 0 like it did in the simple standard deviation, and that's okay. It's because these deviations are occurring a different number of times. There's only 1 of the -3s, there's 2 of the -2s, there's 1 of the -5 of the -1, and so forth. Also notice that you do not have to add anything up in these 2 columns. I whited it out so that you wouldn't think, oh, I need to add some things here. So you're going to find each of the deviations from 40. Remember, 40 is your mean. I know there's so much going on here, it's hard to remember. So I want to go back and remind you where the 40 came from. 40 is your mean. The closing price is your X. And so each of these values is found by taking the X value minus 40. In the next column, you are going to square this value. -3 squared, -2 squared, -1 squared, 0 squared, 1 squared, 2 squared, and 4 squared. And so these are the values there. Now it's this last column that causes people some difficulty. So that's why I drew in these arrows. I want you to understand what's going on here. I don't know if I can put this in here without it throwing things off, but I'll try. So what we're doing here is we're multiplying this column times this column. We're multiplying your frequency value, in this case 1 times 9 to get 9. 2 times 4 gives you 8. 5 times 1 gives you 5, and so forth. So that's why I have this image or these arrows in here, because I want you to understand I'm multiplying the second column times the fifth column to get the value in the sixth column. If you look at the X minus 40 squared, that's this value here. The F is this value over here. And we get all these values here that we add together. Now we do have to add those down, which is why there's a row down here at the bottom. There's no addition needed here, but we do need to add here. So the total that we get when we add the product of our squared deviations in our frequency, we get 50. So now we're going to divide 50 by the number of data values. There are 20 data values. That's the sum of your frequency. Minus 1. Remember, it's always n minus 1. So 50 minus 19 is 2.63, and that is our variance.
Where did we get the 20 from?
The 20 is the total number of scores. If we go back up and look at the problem, there are 20 trading days, right?
Mm.
So the frequency is the same as the number of scores.
Okay.
That make sense?
Yep.
So that's 20 minus 1 is 19. 50 divided by 19 is 2.63, which we call the variance. Then we take the square root of the variance. The square root of 2.63 is approximately, that's an equal sign with a squiggle over it, that means approximately 1.62, which is our standard deviation. Are there any questions? I cannot stress to you enough how important it is for you to practice this stuff. I would even encourage you not just to practice any of the problems I created online, but to go into your textbook and practice some of the odd-numbered problems. It would really be beneficial for you. Obviously, you'll have your book and your notes for taking your tests, but nothing beats practicing and grinding through the problems. Again, I want to go ahead, Chris.
Did you post the final review sheet that you normally post? I haven't looked yet.
I believe so, yes. It's not in the Zoom notes. It's in the regular regular file. But yeah, the final exam review should be posted. I think I posted that last week.
Yeah, there's typically a couple good practice problems for this in there too. So another resource.
Great. Yep, great point. And those are problems that I'll go over, and I'm sure Chris will be happy to go over in SI as well. This problem right here, I just want to remind you, I'll help you get started here, okay? So this is a practice problem. You need to find the mean first. So the first thing you need to do is find out what's the frequency. 3 and 2 is 5 and 6 is 11. 4 is 15, 16, 17, 18, 19, 20. So there are 20 scores. This column, you're going to multiply the first two columns together. So 15 times 3 is 45. 17 times 2 is 34, and so forth. And when you get those, you're going to get a value down here. You divide this value by 20, and you will have your mean. And then you'll be off to the races. I don't want to do it all for you. I will put this in here just in case you wonder, where did that come from? So those are your first two values there, and you can find the rest of them, then add them all up. You'll get a sum in here, and then you're going to divide the sum divided by 20, and that will equal your mean. So that'll get you started right there. If you take I'm not going to resave this and post it, so if you've got your notes printed out and you want to write that down, you can do so. So that's how we calculate the standard deviation. On your final exam, you will be asked to calculate the standard deviation for a simple set of data and for a frequency distribution. I will give you a table just like this on the final, and it's going to, the instructions are simply going to say you'll have the values and frequencies, and it's going to say find the mean, median, mode, range, variance, and standard deviation. Any questions? Okay, then I am going to move on to section 14.4. Let me close this out. And this is where it's going to get interesting, because as I shared with a few people who came in early, I got a new toy yesterday that I've been playing with. I got a new iPad. And part of the reason I got the iPad is because it's going to help me with this specific lesson that you guys are a guinea pig for me now, because I have not taught this lesson using the iPad before. So we'll see how it goes. All right. So we're going to start with what's called the normal distribution. This is 14.4. This is our final section of new material in the textbook. We are in the home stretch, folks. The normal distribution is sometimes called the normal curve, and it's one of the most common distributions of data in statistics. There are a lot of real-life data sets that this applies to. And the characteristics of a normal distribution are that a normal curve is bell-shaped, and the curve is symmetric with respect to the mean, okay? That means that, and by the way, the mean is the highest point of the curve. At that value up there, the mean, median, and mode are all the same. The total area under this curve equals 1, which is equivalent to 100%. So that means that if we're collecting a bunch of data, 100% of the data will fall beneath the curve. And here's where I want to make sure that you understand. And so I'm going to try and do something here. Here's where I'm about to get a little bit scared, because I'm about to try to do this on my computer or on my iPad and share something with you, and hopefully it will work. So I'm going to share this, and iPad, is it showing up? I don't see it showing up. There it is. Can you guys see that curve right there? Chris, is that showing up? Awesome. Okay, excellent. So, oops. Again, you guys are my guinea pigs, so bear with me. I hope that this works well. But another characteristic is that 68% of the data falls within one standard deviation of the mean. So the mean will always be right here at 0, okay? Because 0 represents how far we're deviating from the mean. So our mean is at 0, and the -1, -2, -3, 1, 2, and 3, those are standard deviations away from the mean. So 68% of the data, is that showing up? Can you see that? Is that working? Cool. Again, I'm very nervous. This is the first time using a new tool like this in a classroom. So
looks good.
Awesome. Thank you. I appreciate that, Jason. 68% of the data is going to fall in that range. Now, keep in mind that this curve is symmetric. So if 68% of the data is in that range, that means that 34% is here and 34% is here. I guess I didn't need to do percent part. Okay. So 68% of the data is within 1 standard deviation of the mean. Now, 95% of the data is going to fall within 2 standard deviations of the mean. So from here to here, 95% of the data is in that window between -2 and +2. And then if we go all the way out to -3, and I'm not going to erase everything. If we go all the way out here to -3 and +3, 99.7% of the data, 99.7% falls within 3 standard deviations of the mean. It's not the prettiest, but I think I'm getting my point across. So nearly all the data will be within 3 standard deviations of the mean. These are just general rules, general properties of standard deviation. So, or I'm sorry, of the normal distribution. So let's take a look at a problem in your book on page 761. We're going to look at example number 1, and it says that, trying to get to the right page. It says, suppose that the distribution of scores of 1,000 students who take a standardized intelligence test is a normal distribution. Okay, so they tell us it's normal. If the distribution mean is 450 and its standard deviation is 25, how many scores do we expect to fall between 425 and 475? Well, the first thing I want to do is I want to show you how to set up a problem like this. Let me use my eraser. This is so cool. By the way, I was just going to try and muddle through this, and I was talking to my wife about a week ago, and she said, why don't you just buy an iPad? I'm like, okay. When your wife tells you to go out and spend $500 on an iPad, you don't say no. So, all right, let's look at this situation. The first thing you want to do when you have a problem like this is you want to identify your values first of all, you identify your mean, and then you identify your other values relative to the mean. So in this problem on page 761, it says that the mean is 450. So what you want to do is you want to write your, hang on a second, got to get a pen back here. Go with black. All right. Okay, so our mean, hang on a second, that's a little bit too big of a pen lead. Again, I'm learning here, so, no, go away. Thank you so much for your patience. I couldn't have done this in front of a class that I just met, so. Okay, so the mean is 450. You're gonna put that right at 0. Does everybody see where I wrote that 450 down there? That's the mean. So you put it at 0 because these numbers right here represent the deviation from the mean. Now, it tells us that the standard deviation is 25. So the next thing you should do is you should go up 1, 2, and 3 standard deviations and add 25. So 1 standard deviation above the mean is 475. 2 standard deviations would be 500. 3 standard deviations would be 525. And then going below the mean, we subtract 25. So this would be 425, 400, and 375. Now let me stop for a moment because I'm sure that there are some people who are like, what the heck did you just do? And I want to make sure that everybody is on board. Okay, so we place our mean at 0. That's right here. And then whatever the standard deviation value is, we add that going to the right and we subtract it going to the left. So for example, if they had said that the standard deviation was 10, we would add 10, add 10, add 10. Add 10, add 10, add 10. If they said it was 10, we would subtract 10, subtract 10, subtract 10, going to the left, going to the right. Just so you're on board with that. All right. Are there any questions about how I place these values? It's extremely useful for you to place these values and will be Very helpful on your final, especially. So then the next question, going back to the homework, it says, how many scores do you expect to fall between 425 and 475? Okay, so 425 and 475. 425 is right here. 475 is right here. They want to know how many students you would expect to fall in this red region right here. Now again, what percent of the student, or what percent of the data falls within one standard deviation of the mean? We talked about it earlier.
68.
Very good. 68% falls within one standard deviation of the mean. So that means that 68% of the students are going to be in that red region. So how do we find that? Well, we take 68%, which is a decimal, is 0.68. We multiply it by 1,000, and we get 680 students. I am loving this iPad. 680 students are going to fall in that window because that's within one standard deviation of the mean. Does that make sense? It's not too painful, right? Okay. Let's do part B. And to do part B, I'm going to pull up another graph, a clean graph. We'll save that other one. Part B says, how many students do you expect to fall above 500? Well, again, of course, I did erase my numbers, so I'm going to put those numbers back in. Excuse me. So this was 450. This was 475, 500, 525. And then below we had 425, 400, and 375. So now they're asking the following question. And let's use a different color. Let's use something, let's use an orange. Okay. They want to know how many students fell above 500. So hopefully you are seeing where I'm coloring this in. They want to know how many students are out there in that range. Now let me ask you a question. Do you think there's a lot of students that scored above 500 based on that, the size of that region? Probably a pretty small number, right? Would you agree? So how do we find out what that is? Well, we need to use some logic, okay? We need to use a little bit of logic, and it's not hard. Keep in mind that a certain percentage of students are within 2 standard deviations of the mean. What percentage was that that's within 2 standard deviations of the mean? Talked about it a little earlier.
You said that falls within?
Yeah. What percent falls within
95.
2? Exactly. 95% fall within 2 standard deviations of the mean. Would you agree with that? So then let me ask you a converse question. Yeah, go ahead, Jason.
How did you figure out it was 95%?
That's a given. We gave that to you as one of the characteristics, properties of the normal distribution.
All right, we're good.
Okay. So if you look at properties of the normal distribution, which are at the bottom of page 750, and they're also in your notes, one of the properties is that 95% of the data falls within 2 standard deviations. So it's a given type of thing. All right. So let me ask you this. If 95% of the data is within 2 standard deviations, then how much of the data must be outside of 2 standard deviations?
5%?
5%, right? Exactly right. Good. Yep. A couple people are mentioning that in the chat. Exactly right. So that means that 5% of the data is outside of that. So let me color in that 5% for a minute. The stuff that's outside. We already looked at stuff up here. Let's also look at the stuff now down here that I'm shading in orange as well. Would you agree that the stuff that I've shaded in orange is the stuff that's outside of the 95%? Does that make sense? Does it also make sense then that if there's 5%, that means that half of the 5% must be in there and half of the 5% would be in there? Can we agree with that? Okay, good. So what is half of 5?
2.5.
2.5. I think that's probably popping up for some people in the chat. Yep, 2.5. So that means 2.5% is in there. Does everybody understand that? Is this making sense? I hope. Okay, so then the question is, if that we're looking at this 2.5%, I'm going to write over here in the middle just because of space. So I need to find 2.5% of 1,000 students. You can probably do that on your calculator, or you can use common sense. Can anybody tell me what 2.5% of 1,000 is?
25%.
Not 25%, 25 students. You are correct. It is 25, but it's actually the number of students. So that means that 25 students are scored 500 or above. Any questions on that? Okay. We are going to move on then to the next concept. And in order to do that, I'm going to jump back over to our notes, 14.4. By the way, Jason, there's the properties of a normal distribution you were asking about right there. So I would encourage you to make sure to check that out. The next thing we're going to talk about is a z-score. The z-score represents the number of standard deviations that a data value is from the mean. So for our purposes, we're going to consider the standard deviation and the z-score to be interchangeable values. For example, the previous thing that we looked at 500 in this problem up here. 500 is 2 standard deviations of the mean, so we would say that 500 has a z-score of 2. 425 is 1 standard deviation below the mean, so it has a z-score of -1, and so forth. Now, it's really easy to calculate z-scores if you know the data value, the mean, and the standard deviation. The formula in the book is kind of an ugly formula. I don't like the way that they write the formula in the book, because what they do is they change the value for the mean. They change the symbol for the mean. And I'm not a fan of that. They also change the value for standard deviation. They use Greek letters mu and sigma. I don't like that they changed that. So this is the formula that I encourage you to use. To calculate a z-score, you take the value minus the mean and divide by the standard deviation. It's really that simple. So let's look at an example on page 765. We're going to calculate the z-score for the following information. Again, this is on page 765 in your book. In an effort to combat dog obesity, and by the way, that is a problem. My wife's grandmother actually killed her own dog by feeding her to the point that she died of diabetes. It's a real thing. In an effort to combat dog obesity, the Association for Pet Obesity Prevention has weighed a group of Basenjis. Basenjis are a type of dog. and found the distribution of their weights to be normally distributed. Anytime you see that expression about normal distribution or normally distributed, you know that you're dealing with a normal curve. They tell you that the mean is 20 pounds. That means the average weight of these dogs is 20 pounds with a standard deviation of 3. So that's your S. It says find the corresponding Z-score for a dog in this group that weighs 25 pounds and 16 pounds. So we're looking for the Z-score. In order to calculate a Z-score, we take the actual value. The first value we're going to start with is 25. We subtract the average or the mean of 20, and we divide by 3. So the X value of 25, mean of 20, standard deviation of 3 would be 25 minus 20 over 3, which is 1.6 repeating. Now, folks, be careful. You have to round correctly. 1.6 repeating means 1.66666666, and you're going to round it to the hundredths place. So it's 1.67. This makes a difference because we have to look up that value on a Z-score table. And the value you get with 1.66 and 1.67 are different. So it's very important that you round correctly. So what about the dog that weighed 16 pounds? Again, the mean is still 20. 16 minus 20 is -4. You can have negative Z-scores. -4 over 3 is -1.3 repeating, which is -1.33. Always, always, always round your Z-score to the nearest hundredth. Okay? The nearest hundredth. Very important that you do that. Now that we know that, what if we wanted to find the percent of dogs that fall between -1.33 standard deviations below the mean and 1.67 standard deviations above the mean? I created this image yesterday when I was playing around with my iPad and trying to figure out how it works. So you can see that here. In other words, the percent of dogs within the two vertical lines. You see the vertical red line, that's -1.33. This vertical red line is at about 1.67. And we want to know the percent of dogs in that entire region. I've colored it two different ways. I've colored the regions in two different ways for one very important reason. We're going to use a table, and the table, which by the way in your book is on page 763, the table tells us the area under the curve, under the normal curve, between your Z-score and the mean. Remember, the mean is at 0. So in other words, when we look up -1.33 on our Z-score table, it's going to give us this green shaded area. When we look up 1.67 on the Z-score table, it's going to give us this purple shaded area. And in order to find the total area, we would have to add those two things together. So let's do that. This requires the table on page 763. I have copied it here for your viewing pleasure. I want to remind you, as I just said, the table tells us what percent as a decimal between the mean and the Z-score we're examining. So hang on to these two Z-scores, -1.33 and 1.67. One thing you need to understand is that you can ignore the negative sign when you look up the Z-score. The negative sign is just telling you whether it's below or above the mean. If it's negative, obviously it's below. So we're going to look up the Z-score for 1.33 and 1.67, and then we're going to add those values together. So here's the table from your book. It's shrunk down a little bit, so hopefully you can see it okay. When we look up the Z-score of 1.33, so you go down this first column. These are in tenths. You get down to 1.0, 1.1, 1.2, 1.3, and then you're going to move over to the right. 1.30, 1.31, 1.32, 1.33. I'm going to zoom in a little bit there. And you can see I circled it in green to correspond to the region we were looking at. The Z-score 1.33 corresponds to 0.4082. What that means is that this green region right here is 0.4082, which is 40.82% of the entire curve. So 40.82% of the dogs are in this region. And then when we look up 1.67, we go down the left-hand column to 1.4, 1.5, there's 1.6, 1.60, 1, 2, 3, 4, 5, 6, 1.67. I want you to notice 1.66 and 1.67 have different values. It's important that you round correctly. 0.4525. So again, that means that in this purple region, this is 0.4525 or 45.25% of the dogs are in this region right here. So if we want to know the total number, the total percentage of dogs that fall in this region between the two red vertical lines, we need to add those two values together. 0.4082 plus 0.4525. And when we add those two values together, we get 86.07 or 0.8607, which as a percent is 86.07. So that means that 86.07% of the dogs weigh between 16 and 25 pounds. Are there any questions about how we did this problem? We're going to do another one with several examples, but I want to make sure that you followed that okay. All right, let's go ahead and take a look at another problem. A company installs light bulbs. Now I'm going to go over to my iPad here in a minute so that we can work on these together. So that means that you're not going to be able to see this problem. Hopefully you've printed this out. But it says that a company installs light bulbs. The lifetime of the light bulbs are normally distributed with a mean of 400 and a standard deviation of 75. So before I do that, let's see if I can put in some information here. So the mean of 400, that would be 400 right there, okay? And the standard deviation of 75, that means that if we go all the way back to, let's see, this would be 75 less, 150 less, 225 less. So this would be 175 right there. I'll pull that back, hang on a second. This would be 250. This would be 325. Oops. There's my mean of 400. This would be 475. This would be 550. And this would be 625. That's the first thing that you need to do. It says use the graph below to write in the data stated above. So mean of 400, standard deviation of 75. Then it says what percent of light bulbs should last at least 480 hours? Okay, so I'm going to go over to my iPad now, and I'm going to share that so that we can look together. Get one of those images up here. Share that. Later. Okay. So, just as a reminder, let me write this in black, kind of small. So this was 400, 475, 550. And the first question says, what percent of light bulbs should last at least 480 hours? So 480 hours is going to be just a little bit more than 475. They want to know the percentage of light bulbs that are going to be out here in this region. Does that make sense? If that's 480, which is a little more than 475, we want to know the percent of light bulbs in that region. So we need to find the z-score for 480. Now remember, the z-score is found by taking the value 480 minus the mean. So I'm going to do that up here above. 480 minus the mean of 400 and dividing by the standard deviation of 75. So when I do that, 480 minus 400 is 80 over 75. Can somebody tell me what 80 divided by 75 is? I don't have my calculator with me. I can't believe I'm so prepared with everything else and I don't have a calculator.
1.06, a lot of sixes and then 7.
1.06 repeating. So then
Yeah.
rounded, that would be that would be 1.07. Can we agree with that? Rounded.
All right.
Now, this is important, folks. That value that it just gave me of 1.07, that's the z-score. We're going to go to our table. We'll come back to this in a minute. We're going to go to our table in the book, and we're going to look up 1.07. Stop that. So 1.07, we go down to 1.0, then we go over 0, 1, 2, 3, 4, 5, 6, 7. 1.07 is 0.3577. Does everybody see that? That value right there? Somebody give me confirmation you understand how we got that.
I understand.
Okay, at least one person does. So you got the you got the z-score 1.07. You went down the z column to 1.0. You went over to 7. You had 0.3577. Now what that means is that 0.3577. Going back to share this. That 0.3577. That's this region in here. Okay, that's this region that I just shaded in green. This is 0.3577 because the z-score tells us the value between, or tells us the area between the value, which is 480, and the mean, 0.3577. But we don't want the green area, we want that red area, don't we? So how are we going to find the red area if we only know the green area? Any ideas?
We subtract the green area.
Good, Jason. You're absolutely correct. What do we subtract it from?
The part that's not filled in.
You mean this part? Hang on a second. Let me get a different color. You mean this
Or
part here?
the whole thing, right? Because that would just leave us with the remainder and then the red area.
You're on the right track. Let me ask you this question. Remember we said that a normal distribution is symmetric. So then how much of the data is to the left of the mean? In general, all the data over here to the left of the mean, how much is
50%?
Exactly. Thank you, Ahmad. You're absolutely right. 50%. I did not. Yep, he did post that up there. 50% of it is this way. By the way, yes, Christine, you are right. 0.3577 is 35.77%. That is correct. So what Ahmad said is that half the data is above the mean. He's correct. And half the data is below the mean because it's symmetric. So if we know this green area right here, if we know this green area is 0.3577 and we want the red area, all we need to do to find that red area is to take 50%, which is 0.5000, and subtract the green area of 0.3577, and that's going to tell us the red area. That's going to tell us how much is in that red area. So that's going to be 3, 2, 4, 2. So that red area right there is 0.2423. Which as a percent, if it says what percent?
It's 1423.
Oh, thank you, Chris. Thank you, Chris. 1423. My bad. It's 1423, my subtraction error, which is 14.23%. I went off my screen a little bit. 14.23%. So yes, we had to use subtraction in order to find that red area. Let's do another one. The next problem says, how many light bulbs should last between 300 and 500 hours? Now remember, oops, remember that this is 400, this is 475, this is 550, and this is 325, and this is 250. So if they want to know what percent of the light bulbs are going to last between 300 and 500 hours, so 300 is going to be somewhere in between the 250 and the 325. So I'm just going to kind of pick a value in there that we'll call 300. And 500 is going to be out here somewhere. Let's see, probably around in here like this. So they want to know what percent is going to fall in this entire area. I'm going to shade them different directions because you need to understand that we're going to have to find two different values. Okay, so we need to find this red region, and then we need to find this red region. So we need to calculate z-scores. So the z-score for the right side is going to be 500 minus 450 over 75, which is 50 over 75, which I believe is 0.67. So I'd like somebody to go to the table in the book.
Isn't the mean 400?
It is 400, thank you. I'm noticing that I'm running out of time, and so I'm getting a little bit careless. I apologize for that, folks. I'm going to slow it down. So 500 minus 400 is 100 over 75. And 100 over 75 is 1.33, I think. Somebody check me on that. And then on this side, we've got 300 minus 400 over 75, which is negative 100 over 75, which is negative 1.33. Well, that's good because we don't care about the negative sign when we look up our z-score. So can somebody look up the z-score for 1.33 and tell me what it is? .1423, is that what? No, that's the answer to the previous problem. I'm looking at the typing. .4082, is that what I'm seeing here? So the z-score for 1.33 is 0.4082. That's how much is in this region. It's the same z-score value, so that's how much is in this region. So when we add those together, we get 0.8164 or 81.64%. That is the percent of light bulbs that fall in this red region here. Now we only have 5 minutes left, and I only have 8% left on my phone, on my computer. My iPad's fully charged, but my computer's almost dead. I don't know why. Probably because iPad's sucking away the energy. But I want to point out to you, as we go back to the document we were just looking at. Close this. So these are the problems. We did the first two problems here, okay? I would encourage you to do parts C, D, and E for practice. You can also, you can contact me with any questions. You can contact Chris during SI and ask him if he has any questions. And then what we can do is certainly next week, especially on See, Tuesday you're taking your test. On Thursday, when we do the midterm or final exam review, we can go over these problems in a little more detail. Does anybody have any questions about anything that we talked about today? It is so important that you practice these problems. Really, really important. Many of you are health majors, whether you're nursing majors or you're going into respiratory therapy or something like that. You're going to have to take a course called K300. K300 is a 300 level statistics course, and you're going to see this stuff in there. So this stuff is not going away once you're done with this class for most of you. I think, Jason, aren't you a history major? No? I thought you were a history major. Somebody was a history major.
Political science.
Political science. Okay. All right. Political science. So Jason, you're probably not going to have to take an SI or a statistics class, but many of you are going to. Chris is saying SI is going to be Monday 1 to 3 for anybody who wants help preparing for the test on Tuesday. Remember, Chris is not going to be available or answering any questions once Tuesday hits. So if you need help, you need to contact him during SI on Monday 1 to 3. I will also be checking my email regularly if you have any questions. Also, one more reminder, if you want to set up a private Zoom meeting to go over any of this kind of stuff, send me an email and we'll set something up. Those are office hours, you know, folks. I can't sit in my office at IUN from 11:30 to 3:30, but I can be available via Zoom. So at this point, I'm going to end the recording, and this will be the end of our class for today.